Okay, so today we're going to be going over section 2.6, special functions. So it has two sides on this, these notes, so you need to make sure you're on the same side as I am right now with the example graphs at the bottom. Okay, so there are other types of functions besides linear functions. Some of the special functions are step functions, constant functions, identity functions, absolute value functions, and piecewise functions. All of these functions have unique looking graphs. So at the bottom, they give you examples of each kind of graph except for the identity function. So I'm going to add that one. The identity function is just when you have a line that the slope is 1, the y-intercept is at 0. That's the parent graph because it's the simplest kind of identity function. Okay, so then every other line is a variation of it. It's shifted off at the origin. But this is your parent graph for an identity function. Okay, then you have the step function, and the reason it's called a step function is because when you graph it, it has a little step-like graph. Constant function is just y equals some number. It's going to be a horizontal line. Absolute value function is always in a V shape. Okay, so you know what to expect when you're going to graph an absolute value function. And then you have a piecewise function, which is made up of several parts of other equations. You just put them all together into one. All right, so let's look at the second paragraph. It says a step function is also called a greatest integer function. And you can tell it's a step function because of this notation. It has the double brackets around the variable. An example of a step function could be found in postage rates. If the weight of a package is between 0 and 5 ounces, the cost is 34 cents. If the weight is between 5 and 10 ounces, the cost is 55 cents, and so on. The set of points would be something like, and they give you the set of points, which I'm going to make into a table of values at the bottom of the paper, because we're going to graph this, and maybe it'll help with the step functions later when we're graphing those. So when the weight of your whatever is actually 0, you don't have anything that you're mailing if it's a 0 ounces, right? So we're going to say that there is no cost when you have 0 ounces. You don't have anything that you're mailing when it's 0. Okay, but anything over 0 is going to be 35 cents. So if I have 1 ounce, that's 34 cents, excuse me. 2 ounces is 34 cents. 3, 4, and 5, those are all 34 cents. The amount does not change until you get to right over 5 ounces. So anything over like 5.01 ounces is going to be 55 cents. So we'll go ahead and do that. 5.01 is 55 cents. And then it goes on up with the as whole numbers. Okay, so when we graph this, and I'm just going to graph the first quadrant. The y-axis is the cost. The x-axis is the weight, or the ounces. Okay, so my x-axis, I'm going to put in increments of 2. So 5 is right there between 4 and 6. And this first is 34 cents, and then you have 55 cents here. Okay, so when you're graphing this, at 0 ounces, there's no cost. So I'm going to have an open circle there at 0.34. But anything after that, you're going to have a steady cost of 34 cents until you get to 5 ounces. And that's where the 34 cents ends. Anything over 5 ounces jumps up to 55 cents. So I'm going to have an open circle right above the 5 because it doesn't include 5, but everything over 5. And it's going to stay at that rate, 55 cents, until it gets to 10 ounces. And that's where it's going to stop for 55 cents. Okay, so that's how you are graphing a step function. Your y value stays the same for a certain amount of time on your x, and then it jumps up. Okay, any questions on that? So these are all examples of parent functions of the different types of special functions. So when I say a parent function, you know that I'm talking about the simplest form of whatever function we're talking about. So let's look on the other side. We're going to do some examples for the other side. Okay, piecewise functions are functions that are graphed in pieces determined by the given domain. Step functions are also greatest integer functions. The range is always an integer. Parent functions are the basic function of each type. F of x equals a step function. This is the parent function of the step function because this is your simplest step graph. Okay, so starting on this first part, we're going to graph over the given domain. Y equals negative 2x minus 3, and the domain they want you to show is from negative infinity to 1. This is interval notation that they're showing you what domain to graph over. Okay, so I'm just going to graph the whole line that they give me, and then I'm going to go back and erase the part that I don't want. Okay, just as a first step. After a while, you'll get used to it, and you won't have to do that as much. But just to start, that's how we're going to do it. So my y-intercept is at negative 3, and my slope is negative 2. So I'm going to go up 2, left 1, up 2, left 1. If I go down 2, I'm going to go right 1. So now I can draw my line. Okay, so let's look at the domain. When you're reading a graph, you always start on the left side and go to the right. The graph comes from the negative infinity, so I want to find where on the graph x is 1. Okay, here's the origin, that's where x is 0. There's where x is 1. Go down to the graph, and that's where I want my graph to stop. So I'm going to put an open circle there because 1 is not included. They're using a parenthesis. And everything to the right of that, I'm going to erase because I don't want any of that stuff on my final graph. I'm going to put an arrow on the other end to show that it keeps going to negative infinity. And that is your graph. Any questions? Okay, let's look at the next one. Y equals negative 1, and your domain is from 1 to 6. The 1 is included, 6 is not included. So that means that we're going to have a closed circle at 1 where it starts, open circle at 6 where it stops. So this line y equals negative 1, that's a constant function. It's just a horizontal line where y is negative 1. Okay, my domain that I want to show, part of the graph I want to show is where x is 1. So here is where x is 1. I'm going to put a closed circle there because I have a bracket. That means I want to include the value. I'm going to erase everything to the left of it. Okay, the next part tells me where to stop. I'm going to stop at positive 6. This is where x is positive 6. I'm going to have an open circle there. Erase everything on the other side of it. And that's my graph. So when you're drawing or deciding where to stop and start, the way they write it is from left to right. So you always read a graph from left to right, write it from left to right. Any questions? Okay, you guys try number 3, and I will do it up here. I'm going to give you a little head start, and then I'm going to draw it up on my graph.